Oh, 2.
2. That's it. Nothing more, nothing less. All right, so let's go on to number 19.
Mm-hmm.
All right, so for a 2 by 2 here, to calculate the determinant, you do this butterfly thing. You multiply diagonally here. All right, so that is 4 times 3 minus 1 times -2. So that is 12 minus -2. You can't forget that you're subtracting. If it is negative, the product is negative. You're going to have two negatives there. That becomes 12 plus 2,
So
which
14.
is which is 14. Yeah. All right. So the last one here does require you to graph. You want to get the Desmos graphing calculator out. Um, we'll take a look at that here. So we've got x minus 1 squared over 16 minus y plus 3 squared over 9 equals 1. This is going to be something that either opens left or right or up or down. And you're looking for that place that's kind of right in the middle. They call it the center. I mean, it's the middle. Um, if you need to, you could plot each of these points to figure that out. But could you go ahead and graph that and tell me what you come up with?
Okay. It's a hold on, I forgot the name.
We,
Hyperbola.
yes, we know it's absolutely hyperbola. In fact, that's even given. That's not the question. The question is like, where is the center? Where is this red dot? And it depends. You kind of have to visually inspect these points to figure that out. There is another way, but I'll just suggest looking at these ordered pairs and figure out which ordered pair is in the middle, whichever way it opens.
It goes like side to side.
Okay, so there's a point still right somewhere in the middle. It's one of these.
Yeah.
I can't really help much more other than giving you the answer, which doesn't help much. So um,
Let me see if I can try to find it before you tell me. Um, I think it's 1 comma -3.
yes, that is correct. Very good. All right, so I think that is everything for the review assignment, which is great.
Perfect. We're on fire. And then it's the skill assessment, I think.
Yeah, so I've actually was able to get that loaded up here. So let me new share that, and we'll see if we can figure this out together. You're seeing my screen here. So what I did is I clicked on. I'll just show you what I did. Is I clicked on the link, entered the information, and let's see here. It says looks like you've got to answer some of these questions, but um, looks like you might need to upload a file. So here we go. Math diagnostic. I guess we'll start here. Um, let me know when you're ready. I don't want to proceed too far here until you're
Okay.
sort of on.
Just give me like 1 second.
Yep.
We're getting a new page and stuff. I'm just looking at something. Hmm. I was just looking to see something. Turns out I didn't submit my lesson 35, and I'm just trying to figure that out as to. Oh no, I did submit. I just never got a grade for it. Okay.
Instructor's on holiday, so.
Yeah. Just double checking. Yeah. Okay. Anyway, let's do this. I'm ready.
All right, so some of these questions here, I don't think the answer really matters. They're probably just people taking data. I don't know how you want to answer this.
Hi.
Just
My name is Devin.
Let me know what you think here. If you're not
so
physically in a school, but you are at home doing school.
So basically what happens when you take this diagnostic, so I say no because I'm not in the school building, and then it's gonna go through like a little video, which what you heard earlier, but then I exited out of the page. So when you say no, then they explain to you what's gonna happen and everything. So while I also get the page as well, I'm gonna mute myself so you don't have to hear me listening to it as well.
Yeah.
So is
Okay,
that
so what do you want me to click here? No, then, or
yeah,
yes?
just click no, just click no.
Okay, it looks like we can start here. You must view all the tools before you can continue. Okay. Great. Calculator.
All right.
Okay, so okay, so I'm not sure how to even proceed here, but I think what I'll do is snip these into the other page. And
All right.
I guess the question I have or thought is like, what happens after this? Do you get more lessons to do?
Well, after this, I have no other math courses because I'm taking two this year, so I don't take one next year. And and then I'll like be finished with this math course for this year. So nothing, I won't get any more lessons after this.
Right. But I mean, like, what is the
The purpose.
yeah, I mean, like, I mean, all the things we just read, okay, you don't get a grade, but it sounds like you're going to get new lessons based on this, but you're saying, no, I'm not, I'm done.
Yeah.
Okay. All right. So, I mean, in terms of what we should do, I mean, I don't really have I don't know what to say. I mean, I can help you answer every single one of these, but do you know if it will like stop giving you questions at some point, or if we don't really have much to go off of is what I'm trying to say. So
Yeah,
not sure how to proceed.
I also don't know. Like from the progressing, I think you just have. I think there's a maximum of maybe 50 or 100 questions.
Okay.
I think.
Sounds good. All right, so I'll have you kind of do some of this, depending on the questions. We did not cover this, but what I hope you can do is you can FOIL the left. So could you attempt to do that for us, please? And I guess take some notes, because maybe you have to submit these, we don't really know.
Okay, so I FOILed one, and then I got x squared plus 4x plus 4.
But
And that's
so,
gonna be the same thing for the other one.
right. And that's good. So now, and this is how to answer it, is you have to, this is where it gets a little bit cumbersome, but you take x squared and multiply it by everything on the right, then 4x by everything on the right, then 4 by everything on the right, and then you combine your results here. So for example, this becomes x to the 4th plus 4x cubed plus 4x squared. So that's this x squared times each of those. And then we'll do the same thing for 4x. It ends up being 4x cubed plus 16x squared plus 16. So this is called the waterfall approach. You can imagine water kind of flowing down. We'll see this again last. So now we're going to take 4 times each of these. 4x squared plus, sorry, that's supposed to be an x, 16x plus 16. And then if you notice the way this is written, you can add them all up vertically. X to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. And then you have to decide if any of these answers are there, or any of these terms are there. I'm sorry, is there an x to the 4th? Is there an 8x squared? Is there 24x squared? Is there 32x? Is there a 16?
There's a 16.
16x though, that's
Yeah.
different. Just look one more time. X to
Oh,
the 4th, 8x cubed, 24x squared, 32x plus 16. Any of those appear in this list?
4x squared.
Yeah, very good. Okay. So this is different than what you've been doing. So it's oops, no, I don't want to do that. Sorry. Disregard what I have. So I accidentally checked one of the answers by just being bad with my mouse. So, okay. 7x over x squared minus 4 and 2 over x plus 2. Do you remember at all how to add up rationals like this? It's okay if you don't, I'm just asking.
I don't remember this.
Okay, so first thing you have to do is make a common denominator. And you do that by first factoring x squared minus 4. Do you remember how to factor x squared minus 4? Difference of squares. So this becomes x minus 2, x plus 2. So the way this works, and I'll just rewrite it here. X minus 2, x plus 2, plus 2 over x plus 2. You look at what's on the left here and you say, okay, what is missing? Like what does the left have that the right does not have? Just looking at the bottom. What does the left have that the right does not have? What's
It has
missing
an
here?
it has another parentheses,
Okay, and what's inside the parentheses?
x plus 2.
You already have that though. What is missing? What is
Oh, there's
missing?
an x minus 2. That's what it's
Okay.
missing.
Yes. Yes. So we're going to put x minus 2 here and x minus 2 here. All right. So now what you can do when you have a common denominator, they're now the same, is you can combine the top. But you keep the bottom.
Okay.
So you keep the bottom. All right, so I want you to look at just the top here and try to simplify that for me, please.
Okay.
Just the top, nothing to do with the bottom.
It would be like 7x plus 2x minus 4 because I distributed the 2.
Okay, keep going.
So when I do that, it's going to be 9x minus 4.
Yes, very good. Okay, so that is the top. And then the bottom, well, it's currently in factored form, but you could FOIL it and it would get back to the other form. Okay. So let me, sorry, I'm just looking at the answers. Let me go, actually, that would be more helpful for you to see them. All right, so let me put the answers here. So this, what you have is correct, but you have to match it to one of the answers that's given there. Which one do you see that matches it?
The first, like the first one, the top left.
Very good. Yes. Okay. So let's take a look at this one here. All right. So it says, what is the minimum value of the function x squared minus 6x minus 12? Can you try to tell me what you think it means by minimum value?
Minimum volume, like the smallest
Right.
or the
Very
most
good. So
simple?
does this have a minimum value? What I've drawn here?
No.
Does this have a minimum value?
I'm gonna say no again, but I'm pretty sure I'm wrong when I say that.
Okay. So what's the difference between these two?
Okay, one's like negative and one's positive, right?
Yeah. I mean, one opens up, one opens down.
Yeah. If the one with the minimum volume, it would likely be the one that opens down.
So the one on the left here that opens down,
Yeah.
it does not have a minimum. It has a maximum.
Oh, dang it.
Okay. If you've ever been hiking, the maximum is like the peak. You get to the top, there's no more, no further to go.
Oh, yeah.
In this other one, a little bit more difficult to think about because we usually don't climb to the bottom, but you can think of being here at the bottom. The bottom is the minimum. Okay. Now, this is a graph of a quadratic. Do you remember the name of the min and the max? What's another name for that?
Um,
So the
um,
vertex is the min or the max.
yeah, it was on
Okay.
the tip of my tongue because I remember you told me and then I just forgot about it. And I'm like, no, it starts with a V, but I just didn't name.
The vertex has both an x and a y value because it's an ordered pair. This place down at the bottom, this place at the top, it's an ordered pair. It's got an x and a y value. You just want the y value. Okay. So here's what I want you to do. I want you to graph what's up here at the top, x squared minus 6x minus 12, and give me the y value, just the y value at the bottom.
Just the Y value, okay. Well, looking from our like our problem that I don't see the Y value because I only see the like what's on the X side of everything. So
You can just graph x squared minus 6x minus 12. And if you want, you can put a y equals, but just graph this in Desmos and y1.
okay. Okay, so I graphed it and it is like now I just gotta go look at the points to see what it is. So when I graph it in Desmos, do I do y equals x squared minus 6x minus 12, or do I keep it with the g?
You can graph it without the y, just x squared minus 6x minus 12, or you can put the y equals in. Either way will work.
Okay, because I did it with the y equals and yeah. Okay, so I graphed it. Now I just gotta find the the y value.
The y value of the vertex, the min or the max. In this case, it's the min.
So it's gonna be and that's gonna be 3 comma negative 21.
Okay, what did I ask you though for?
The y value.
Yes. So what are you gonna tell me? Imagine I only want to hear one number.
Oh, sorry, negative 21.
That's it.
I said the whole point instead of just
Yes.
saying one because I don't know. I have a habit of saying both.
Right. So a new problem here. This one is this one we didn't cover really any of this, at least in the parts of the the class here. So but that's okay. So f of 2x is a transformation.
Okay.
Okay, and it's actually very
It looks like a transformation.
it's hard to explain this one because it's a horizontal transformation. But we can do this with some ordered pairs. So I know it's a little bit hard to see, but maybe you have to do that. Give me that one, that one. These aren't going to work out that way. That's okay. Sometimes they don't give you very good values to work with. So let's see here. Let's see here. We got negative 2, 0, 0, 0, and 2, 0.
Okay.
So we're going to now transform these. The thing I'm trying to decide here is if I should just give you the answer or not. It's like these are just okay. So do you remember like when we would say like x minus 1 squared, and this means 1 right? And maybe something like x plus 3 squared means 3 left. Do you remember any sort of discussions that we had, or you've seen that before?
I think so. Um, oh, I remember doing these. It was like,
But do you remember this? Because that's the basis for what I want to say, and I don't want to go further if that's not clear.
yeah, I do remember these.
Okay, so the thing is it like backwards? It's like why is minus 1 right and plus 3 left? It's just backwards. And I mean, we can get into why that is. That's not really important, but you might think that 2 is a multiplier, but it's not. It's actually, you actually end up dividing the x values by 2. So every x value you're dividing by 2, and there's no change to the y values, except yeah, right there. So the idea here is that these blue, I'll graph the new points in blue. There's one there, there's one there, and there's one there, and then these other ones sort of squeeze in. And so you're looking for a graph that's squeezed in. So this, even though it's a number bigger than 1, it ends up pushing it in, pushing the graph in, kind of squeezing it. So it's okay if that didn't make a ton of sense here. We're going to look at the problem here again with this. So what I want to show you is the original graphs up here. And this one on the left, you can see that it got wider. Do you
Right.
agree with that? Like, I hate to make an analogy to waistline, but it's like your waist got wider. You know, that's could be maybe you ate too much. The next one here has been pulled down.
Mm-hmm.
I don't know how easy that is to see, but you can imagine like this point right here where my cursor is compared to this point, it's been pulled down.
Yeah.
This one next has been squeezed in, narrowed, if you will. And this last one has been pulled. All right, so the one that best matches what we've talked about is this one right here. Any thoughts on that? Questions?
No.
All right, great.
All right.
Okay, finally, a question that we've actually finally a question that we've actually looked at here. So you remember us doing logarithms a little bit?
Yeah. Those
Okay.
were annoying.
I mean, I know we've done it, right? You've seen them, but might have been a week ago or more. All right, so the first thing to do here is to add 3 to both sides. This becomes log base 2 of x equals 4. I'm going to check the Desmos Scientific and see if it does have a log base 2. I don't remember if it does. It does not, does it? Log does not. Okay. We're gonna, without getting into how to do it on there, we're gonna have to undo it a different way. Do you remember how to undo log base 2 from our previous lessons?
Yeah, a little bit, I think.
Okay, so now I'm gonna actually ask you what we should do to undo log base 2. Do you remember what number we apply here out in front?
Don't we apply the 2?
Exactly. Yeah, 2 there and 2 there. So on the left, it completely undoes that. It's just x equals 2 to the 4th. Now, if you look at the answers, is
There.
that there?
It's right there. There's 2 to the 4th.
There it is. You got it. Okay. I think I'm gonna have to do this a little bit differently. I do this with SAT prep as I sort of give a little bit of background before we do the question, which I guess is necessary. So these are the answers. So I want to just talk about each of these uh, functions. So could you graph this in Desmos, please?
Yeah, sure. Oh, wow. That graph automatically starts at 0 and then, um,
If you were to use a letter to describe the graph, what letter would
it's
you
a
say?
V. It's
It's
a
a
V.
V, right? It's a V function, yeah. All right, now I'm trying to figure out how to do this next one. That's not what I want. Let me try something real quick. Okay. So for this next one, I want you to, and this probably look, well, I'm sorry, we'll get to that one. For this one, let's just type in y equals that. Could you graph that for us, please?
Sure. Okay, now it's, so when I graphed it, it's like a, not a horizontal, it's a sideways type line. It's going,
Okay. Do you still have up the absolute value
yeah,
function?
I do.
Do you see that it overlaps with the right part of it?
Yes. I just didn't know how to describe it.
Good. No, it's no big deal. Okay, now the next one, this is the one I was trying to look up. This one's a little bit awkward. Um I want you to graph y equals and type in the word floor, FL of R parentheses X.
It just looks like there's a bunch of, it looks like there's stairs on the overlapping line.
Exactly, yeah. All right, and then could you graph the last one for us, please?
Sure. Okay, now this one has a little curve from,
That has a little curvature to it. Yeah, good. Okay. All right, now here's the actual question. I'd like you to read it to yourself, and then we'll talk about it.
um,
Have you read the question?
yeah, I'm reading it.
Okay. Let me know when you've read it. You don't have to answer the question. I'm going to give you some more information. Just want to make sure you've read it and understand what it's asking for.
Okay, I read it.
Perfect. Okay. So we're going to make a table here, ounces and then cost. Okay. So let's say something is 1 ounce. How much does it cost? That information's in the first sentence.
Hmm. Can you say that one more time, please?
I'm asking you, how much does a 1 ounce letter cost to mail? 1 ounce, and that's in the first sentence here.
It's 20 cents.
Good. 20 cents is the additional ounce cost.
Oh, oops. So it's a dollar and not a dollar, sorry, 46 cents.
All right, so it's $1.46. Now, this is what I think is unclear. Is, let's say it weighs 0.8 ounces. That is also 46 cents. Let's say it weighs 0.6 ounces. That is also 0.46 cents. Okay. Now you just mentioned it, but what happens? What happens the moment that it's more than 1 ounce? What happens to the cost? You just mentioned it.
The cost is 20 cents.
For each additional ounce.
Yeah.
So if something is 2 ounces, it's the $sign 0.46 plus the 20 cents, which is 0.66 dollars. That's what's meant by the additional ounce. Okay. Now,
Yeah.
this is what is also important. Let's say you have a 1.5 ounce letter. The cost is 0.46 for the first ounce, but when it says any portion of an ounce, they're saying that because it's more than 1 ounce, you have to pay the cost of 2 ounces, even though you don't have 2 ounces. So the cost here is also 0.46 plus 0.2, which is 0.66. And let's say it's 1.7 ounces. It's still 0.46 plus 0.2. So that first ounce is the 0.46. Anything more than that is this 0.2. Okay. And I don't expect you to fully understand that, but now we're going to graph it. Okay, so we're gonna make a plot at 1 ounce and 46 cents. So here's we'll just call this 1 ounce right there, and we'll call this 0.46. Actually, let me just move that down. Just so we need more room there for the next one. That's 0.46. Okay, so 1.46, 0.8, 0.46, and 0.6. What do you see here? Kind of a step, right?
Yeah.
Let's say it's 2 ounces. Well, we know 2 ounces, it goes up to 0.66 cents. But so is 1.5 and 1.7. What do you see here? Which of these graphs does it look like?
It looks like the floor one.
The steps, yes.
Yeah, step function.
Yes. So there's no in between. There's no like, and this is true. This is the way the Postal Service works. Is if you have 1.0001 ounces, it goes up to the next cost. And that's what this is called. It's called like a jump, basically. A jump to there.
Mhm.
All right. Okay. Yeah, so this was definitely not covered in this class. So this is one of those things where I'm not sure if we should, like, do you think we should skip problems that were definitely not covered in this class?
Now let's just go
Let's
for
do
them.
them.
Yeah.
Okay. So here's what I want you to do. I want you to go to your Desmos Scientific. Okay, that's the calculator. And you'll see a little button there that says DEG.
Okay.
If you click on it, which is what I want you to do, click on it, you will see that it slides. It's really a slider. It slides to RAD.
Yeah.
Okay. And so once you've done that, what I want you to do is put this tangent 5 pi over 6 in the calculator, then each of these in the calculator, and one of them will be the same.
Okay. So when I did the tangent stuff in Desmos, I only see the decimal version and I can't somehow change it into a fraction.
It's okay. That's okay. So you're gonna do this. These are all gonna be decimals, and you're looking for the one that's exactly the same.
Okay. So when I
Good.
did the tangent, I got negative 0.577.
That's right. Now you've got to hit enter and put each of these ones into the next row. I don't know if we've talked about that feature, but you can keep hitting enter to keep the values. Let me just show you that here.
Mhm.
So like what I've done is put the first one in, hit enter, then do the second one, hit enter. You can copy and paste.
Okay.
It'll just be right back.
Okay. I think it's the tangent negative pi over 6 is that one. Okay, I got my answer. Hmm.
All right, I'm back. How are you
Hi.
doing on this one?
I think I got the answer.
What is the answer?
The negative pi over 6 one.
You are correct. Good. So, in full disclosure, this is how some students do this part of the course. Uh, this is not the best way, but it's allowed. So, um, all right. So let's take a look at the next one. We did do um, some problems like this. Okay, so the inverse is a recipe. It's y equals x over x minus 2, like that. And the first step after you put a y in is you switch x and y. So x equals y over y minus 2, like that. And now you have to solve for y. This is take a deep breath. You're like, all right, we've got a little bit of work to do here. So to do this, we're going to first multiply both sides by y minus 2, like that. And then this is xy minus 2x equals y, like that. Is that okay so far?
Yeah.
All right. And then let me just take a look at the answers because they see what they do. Okay. Because it's multiple choice, there's a certain way to do it to make it more look like the multiple choice. So I'm going to subtract xy from both sides. And notice I can't combine it with this side. I just have to leave it. And now I can factor out a y. So this is y times 1 minus x, like that. And then you can divide both sides by 1 minus x. So y is equal to minus 2x over 1 minus x. Okay, so just switch sides there. Is that okay so far?
Yeah.
Okay. Now this is a more advanced approach. Sometimes they take a negative out of the bottom. So the way that works is it's really negative 1 plus x. Imagine factor out a negative 1. So this looks a little bit weird. So if you reorder it, x minus 1 with that negative there, these two negatives cancel. So you end up getting 2x over x minus 1. Now, all of that last little bit was necessary to determine the correct answer. Because the correct answer, you can see here, didn't have a minus 2x. There was a minus 2x there, but it had an x minus 1. This is a 2x over x minus 1. That's that one there.
Mm-hmm.
Is that okay?
Yeah, that's fine.
Okay. This is really tough. All right. Boy. Okay. Your course didn't really prepare you for questions like these. Say that. Okay. Which statement describes if there is an extraneous solution to the equation given here? So there's apparently two solutions, 7 and 4. All right. So what we're going to do is we're going to put in 7 and 4 into this. So we're going to try 7 and then we're going to try 4. All right, so we're going to try 7 over here on the left. Square root of 7 minus 3, does that equal 7 minus 5? Could you simplify the left-hand side for us and the right-hand side and tell me if they're the same?
Okay, so 7 minus 3 is 4. So the square
Okay,
root of 4 equals 7 minus 5 is 2. And the square root of 4 is 2, so that one works.
good. So now we're going to try 4. Square root of 4 minus 3, does that equal 4 minus 5?
Okay, so 4 minus 3 is 1. And 4 minus 5 is -1. The negative won't work.
Well, are these the same? You just be careful here because you said this, it's the square root of 1.
Well, yeah, I would say it's, well, I mean, yeah, I could say it's the same.
Okay,
Technically.
I wasn't trying to be deceptive. I was just trying to get you to give this is an important step here to take the square root. What is the square root of 1?
Okay. I'm gonna say they're the same then.
No, you got to answer my question. What is the square root of 1?
Just one.
Just 1. Okay. Now, are these the same?
Okay. Now are they the same? Yeah, no,
They're not.
yeah,
They're not. So this one is extraneous. All right. So the last one here is correct here. That one is extraneous. Okay. We're going to go ahead and stop there for right now. We
Okay.
got another lesson at